Hello everyone, my name is Fatima Harayat and I'm going to explain the experiment number 2 for your course Fluid Mechanics first. So what we have in the experiment number 2 is the impact of the jet, and what we want to calculate is the force exerted from the water coming from a jet to the deflector and the flow rate of the water. So you have all of these schematics in your manual. So what we have is just an inlet pipe coming through a nozzle, and the diameter of nozzle is given as 8 millimeters. The water hits a target plate and deflects, and then initially everything is level, so we have a level gauge. So when we have zero force coming from the water, it's level. But after the water hits the deflector, it comes up. What you need to do in this experiment is to put weight on the top of this plate. So again, leveling everything, balancing it with the force of the water. So that's way you can have the force of the water experimentally. So just coming to the theoretics, you have all of this in formula in your manual. So simply by having the velocity coming from the flow rate, as I will describe, and having these weights, you can easily measure the force and then plot the weight versus the velocity to the power of 2 for having this slope. Since you have all the angles, and in this experiment you have two different deflections. One of them is flat, another one is cone, is given all the angles. So this one should have a theoretical value which should be compared to the value that you will measure and calculate through this experiment. So going to the device itself, what we have here, this is the where the water comes through this nozzle and then hits the deflector, and as you can see, can moves it up. So you have a spring here, and initially, as you can see, you have a level gauge here. Yeah, the tip of this cone should be completely horizontally in line with the line around the circle. So at first, everything is in balance. So after I turn up the pump and the water comes up, it will hit it up, and then you should put weights on top of it so that it's balanced again, and the force coming from the water is balanced with the weights. So another thing that you have in the experiment should measure is the flow rate. So how you do this one, you have a tank here similar to the experiment number 1, and what happens is that water comes to this tank, and using this little measurement here, it just, the level of the water, the level of height of the water goes up. So what you do is you should take time using a chronometer, and then, for example, after 20 seconds, you would have 5 liters of water accumulated in the tank, and then simply you can calculate the flow rate, 5 liters in 20 seconds. So using the flow rate, you can have the velocity, and then using the weights, you can have the force, so you can compare the theoretical values with the ones that you can get from this experiment. So what I do is that I just put my hands here, because after water hits it, it just goes up. I turn up the pump. After everything reaches steady state, you can see that it comes up. So what I need to do is to put force on top of it, and then on each weight you know how much is the mass of the weight. So it's, for example, 100 grams. I then put another 100, and somehow it's level. This is good for this one. So what I have is 200 grams of mass. So I can easily convert it to weight. And for the velocity and flow rate, what I do, I just close the exit of the tank, and I'll wait until the height of the water reaches 0. Meanwhile, I'll take time. As soon as it reaches 0, okay. And for example, after 20 seconds, not important. Here, 5. So 5 liters of water in around 20 seconds, so I can easily calculate for this one, you have this table in your manual. Okay? You have this table in your manual. What you need to measure is the nozzle diameter, which you have 8 millimeters. Then you have the deflector type that, as I said, there are two different types of the deflector. I will change it and I will show you how you can change the deflector type. But here you have a flat, so as you can see, alpha will be 90 degrees, and for this cone, alpha will be 100 degrees. Okay, based on what you have in your manual. So you have the deflector type. You have the volume collected in the tank, as I showed. You have the time, and using all of the, and you have the mass applied on the top of the weight that you put on the top of the plate. So easily you can calculate Q, velocity to the power of 2. You can calculate force using the formula you have, and you can calculate the slope of the plotted shift curve, the W versus the velocity to the power of 2. So, and you have the theoretical slope based on the alpha and everything that you have angles. So easily you can compare these two. So in order to change the weight, what we do is first we turn off the pump. We wait until everything is on the state. Okay. I just turn this bulb quite gently. So I can put it up like this. Okay. As you can see, here you have a bubble. Then everything should be completely horizontal when you put it in place, and this bubble should be concentric with the circle that you have here. So simply what you do is to change the deflector type from flat. As you can see, this one was flat, and then changing it with the cone. And repeat the experiment 3 times with this one. We will do the measurements, we will give you the numbers, and you can do the calculations. Again, I'll put it on top of this, and then I will fasten everything. I think that we're done for this part.